Hi, and welcome to the online lecture for section 6.6, where we will be looking at solving rational equations. Now, the goal of any college algebra chapter, for the most part, is to get to the point where we can solve equations. Right? Because what we've done so far is introduce a new type of function or extend the types of functions that we are allowed to look at and use to model the real world. And now that we have these equations that we can use these new types of expressions, in our case rational expressions, we want to be able to solve. That is, we've got a formula. We're plugging in numbers, but we're going to have a missing number. We're going to have a missing piece. That's what algebra is all about, is finding that missing number. And so now in section 6.6 we're ready with all the tools that we have to dive in and actually start solving those equations. Now, back in section 5, that is actually chapter 5, we talked about solving polynomials. Now, solving polynomial equations were basically factoring. You set it equal to 0, you get it equal to 0, you factor, you set each factor equal to 0. Now, that trick of getting equal to 0 and setting each factor equal to 0 in effect takes polynomials and turns them into linear equations. And solving linear equations are the easiest types of solves there are, because all you got to do then is move things around till you get the x by itself. Okay? But we had that trick. We had this little technique that turned polynomials into linear equations. Well, now what we're going to do is we're going to introduce a technique. I still call it a trick. I like to think of mathematics sometimes as mathemagic. Right? There's this little trick, but you got a little secret. Once you know the secret, it works. And I'm not like a magician that's not going to tell you the secret. I'm all about telling you everything there is to know about the secret. It's no secret at all. It's just a technique, a thing that you can do that will take rational equations with rational functions, and get rid of the fractions. One little step that's going to get rid of all the fractions in the problem. Once all the fractions are gone, you now know how to solve it just like it's old school, right? We kick it old school then because we just know how the techniques to solve we already have learned, we've mastered, we've got those things down. Okay? So let's take a look at what that trick for getting rid of the fractions is. So the steps to solving a rational equation are given as follows. What you're going to do is you're going to list the restrictions on the variable. What that means is ahead of time you're going to decide what values are not your solution. And you can usually do that relatively quickly by just checking the fractions that are in the problem and to avoid any values which make the denominator 0. Because obviously, if you get a solution that makes the denominator 0, that can't actually be a solution, because plugging that in to the equation to see if it satisfies it shows you that there is in fact a restricted value. That is something that makes that equation undefined. So we can't divide by 0, so those things are going to be off limits from the very beginning. So that's just kind of a preliminary step so that you know which answers aren't actually possible. So the next step is to clear the equation of any fractions. And the trick for doing that is the same technique that we used back in section 6.3 when we were looking at complex fractions. We multiplied the numerator and the denominator by the LCD, the lowest common denominator, of every fraction in that fraction. That got rid of the fractions. Well, that's the same trick we're using here. We can now multiply both sides of the equation by the LCD, and that will get rid of all the fractions. So multiply both sides by the LCD of all rational expressions in the equation. Once you do that, once you get to this point, it's no longer a rational equation. It's polynomial, or it's linear. It's one we already know how to solve. So we just solve the equation. We need to reject any proposed solution that is in the list of restrictions, because it's still possible that we get an answer where it's a restricted value, but our technique gave us that as a solution. If that's true, then we just mark it out. We say that's not an actual solution. Okay, and then we check the remaining solutions just to confirm. That's a nice thing about solving equations. You can always plug it back in to make sure that it's correct. Okay, so let's look at this example that we see right here. In this problem, we're going to start by listing the restrictions. What is it that x cannot be? Right? Well, you look at both the denominators. Just actually look at them one at a time. What can x not be that would make that denominator 0? What would make 2x equal to 0? Well, x clearly can't be 0 then, because if x is 0, we have a 0 in the denominator. That fraction's undefined, so it's not a solution. Same thing's true of this one. Whatever makes 5x equal to 0 is also restricted, so x can't be 0. Now step 2 is to find the LCD. And the LCD in our case is going to be 10x, right? Because 10 is the smallest number that both 2 and 5 go into, and we need to list x to the highest power that it appears. Now we multiply everything by 10x. That's step 2. So 10x times each fraction here, times every term in there, gives me the following. If I take 10x times x plus 6 over 2x, right, the x's cancel, the 2 cancels, and leaves 5 behind. So I have 5 times x plus 6. If I take the 10x times the next fraction, the x's cancel. 5 goes into 10 twice. So I have plus a 2 times x plus 24 equals, and then I take the 10x times the other side. 10x times 2 is 20x. The resulting equation now has no fractions in it. Let me scroll down a little bit for more space. Now I'm just going to solve this, which means simplify both sides and try to get the x by itself if I can. I have 5x plus 30, which we get from distributing here. Take the 2, multiply it times those. I'll have plus 2x plus 48 is equal to 20x. Combining like terms on the left gives me a 7x plus 78 equals 20x. I'm going to subtract 7x from both sides. Gives me 78 is equal to 13x. Divide both sides by 13. And that gives me x is equal to 6. Now check, is that in my restrictions? No, it's not restricted. If it had been restricted, I would just mark it out. But in this case, it's not restricted, so it is a valid answer. Now you can check, plug that back in, see if it satisfies the original equation. For the sake of the lecture, I'm not going to go through that step because we've got it correct. In this example, we have x minus 3 divided by x plus 1 equals x minus 2 divided by x plus 6. Step 1, as before, is to list any restrictions, that is, values that make the denominator 0. In many cases, you will be able to just eyeball this thing, look at the denominators, and see whether or not there's a value for x that makes it equal to 0, as in this case. Clearly, if x plus 1 is in the denominator, x cannot be a negative 1, because that would make that 0. In the second denominator, x could not be negative 6. Alternatively, if it's a little bit harder to just see by looking at it, you might want to set the denominator equal to 0 and solve that. So x would be equal to negative 1 by moving the 1 to the other side. And that's where we get that first restriction. Similarly, you would get negative 6 from the other denominator. Second thing you need to find is the LCD. In some cases, you'll have to factor. In this case, fortunately, all we've got to do is list each factor to the highest power that it appears. So x plus 1 will be included, and x plus 6, both of the first power, and multiplied together. So now we take the LCD, and we're going to multiply both sides of this by that LCD. If we distribute this to each fraction, here's what we get. We'll have the x plus 1 times x plus 6 times x minus 3 over x plus 1 equals x minus 2 over x plus 6, multiplying that by x plus 1, x plus 6 again in both cases. So the x plus 1s cancel out on the left hand side, and I'm left with x plus 6 times x minus 3. On the right hand side, the x plus 6's cancel out, and so I'm left with x minus 2 times x plus 1. Now we've gotten rid of the fractions. right? That's what the whole trick of multiplying through by the LCD allows us to do. Okay? So let's multiply out both sides so we can begin simplifying this and solving. We all have x squared minus 3x plus 6x is plus 3x. 6 times minus 3 is minus 18 equals x squared. We'll have a minus x minus 2. We're at minus 2x and plus x is minus x. And then minus 2 times 1 is minus 2. Now as I try to move things around and get this thing equal to 0, I will subtract x squared from both sides. At this point you realize that in fact even though I had squares in there, this is not going to be a quadratic equation, not one that I have to solve using factoring, because the x squareds drop out after this step, and I'm left with 3x minus 18 is equal to negative x minus 2. And as I try to move the x's and the numbers around to get x by itself, we see the following happens. I'm going to add x to both sides to get the x over here, and I'm going to add 18 to both sides to get the 18 over here. So 3x plus x, let's write that over here. We're going to get 4x, the 18 subtract out, the x's subtract out, we'll have that equal to 16. Alright, so now, solving for x, divide both sides by 4, we'll have x is equal to 4. Now double check, is that in my list of restricted values? No, it's not. So that is a valid answer. I could go back and check it, but we're going to go ahead and block that off and say, well, we're done. Now we're ready for two more examples. Let's do example C. We have 8x divided by x plus 1 is equal to 4 minus 8 divided by x plus 1. Start again with the restrictions. Another one that we are easily able to tell just by looking that the only value that's not allowed, negative 1. Right? Negative 1 would make the denominator here 0. Alright, second step, LCD. We only have one denominator, although it appears twice, it's x plus 1. So I'm going to take x plus 1, and that's what I'm going to multiply through across all of the terms in this equation. If you take x plus 1 times the first fraction, right? X plus 1, 8x over x plus 1. You're going to see the x plus 1's cancel. On the other side, we're going to have, make sure you do it times each thing because you got a minus sign, so you got to distribute across subtraction. So we'll have a 4 times x plus 1, and we'll have the 8 over x plus 1 times the x plus 1. So everything times x plus 1. Over here, the x plus 1's will divide out, and you're left with 8x. Over here, then multiply those together, 4x plus 4, and the x plus 1 subtract out, or sorry, divide out, and I'm left with a minus 8. Okay, so let's see what I get. Combine these together, I'll have 4x minus 4 is equal to 8x. Subtract the 4x from both sides. 4x is equal to negative 4. Divide both sides by 4, and I get x is equal to negative 1. Now, what do you notice about that? It's restricted. Okay, which means we mark it out. We still got the answer from the technique, but at this point we have to evaluate it and say, is that actually a solution? The answer is no. It doesn't solve the original equation. It solved the resulting equation after we multiplied through by the LCD, but the original equation had denominators of x plus 1, so x equals negative 1 would leave values undefined in the equation. So it's actually not true. Now if you mark out all the answers, then your final answer is no solution. That is, there is no solution to this equation, which sometimes is just as helpful information as having a solution. That is, you know that there is no x. It's not that we haven't found one yet or haven't been able to find one. It's that we can't find one. It's not possible. There is no equation. No solution to that equation. Okay? All right, then let's move on to the next example. The next example, we again start with the same process all the way through. And this whole section is basically us just doing examples of those 5 steps that I gave you, 4 steps that I gave you on the previous page. So what restriction do we have here? What can x not be? X is not equal to, well, that denominator is never going to be 0, but this one right here is 0 if x is 0. so x can't be 0. What is our LCD? Well, our LCD is going to take each of our denominators, so it's going to be 2 and x. Multiply through by 2x. Are you starting to get the hang of this? I hope so. If not, keep watching. Keep trying to get the hang of it. 2x times x over 2, the 2's cancel. I'm left with x squared. 2x times 12 over the x's cancel. So we end up with 24, and 2x times 5 is equal to 10x. In this case, we actually do have a squared term that's not going to subtract out, so we can't get x by itself in the form that this equation is in now. So it's a quadratic or a polynomial equation. We've got to use a different technique to solve. Right up here we were just moving things around. Now we got to use the fact that with the square, the first power term, and the constant term, we need to get this equal to 0 first. So subtract 10x from both sides. So you have x squared minus 10x plus 24 equals 0. Then you factor, set each factor equal to 0, and you're done. So factoring, we get x, we know they're both minus. Two things multiply together to give me 24, but add together to give me 10 would be 6 and 4. So we let x minus 6 equals 0, and x minus 4 equals 0, gives me x is equal to 6, and x is equal to 4. We got two different answers. Now, are either of them restricted? Well, no. They both are not restricted, so they are both answers. In this example, we have x divided by x minus 3 plus 5 divided by x minus 4 is equal to x squared minus 20, all divided by x squared minus 7x plus 12. Start with the restrictions. Alright, so x minus 3 means x cannot be 3. X minus 4 means x cannot be 4. Now what about the denominator on the right hand side? Well, to figure that out, we're going to have to set it equal to 0 and solve that equation. This is still just to find out the restrictions. Because it's already equal to 0, I can factor x minus 3 and 4 equals 0. Notice, of course, that we get the same two equations we just solved, or the same two problems we just had. X cannot be 3, x cannot be 4. So we've got those included in our list of restrictions. Alright, so this right here we just saw is the same thing as x minus 3, x minus 4. I'm going to go ahead and write that in over here because that saves me a step in finding the LCD. The LCD will list every factor that we see to the highest power that it appears. Now x minus 3 is both here and on the right hand side, but they're both to the first power. X minus 4 is in both places as well. So our LCD will be x minus 3 times x minus 4. So I'm going to multiply everything times x minus 3 times x minus 4. Now when I take that times the first fraction, the x minus 3's will cancel, and I will be left with x times x minus 4. When I take that times the next fraction, the x minus 4's will cancel, and I'll be left with 5 times x minus 3. And when I multiply times the right hand side, everything cancels, and I'm left with x squared minus 20. Now let's simplify both sides to be able to solve for x. I'll have distributing this, x squared minus 4x plus 5x minus 15 is equal to x squared minus 20. I'll have x squared plus x minus 15 is equal to x squared minus 20. If I subtract x squared from both sides, they clearly cancel out. Add 15 to both sides, I will have x is equal to negative 5. If x is equal to negative 5 is not a restricted value. Thus, that is our final answer. Alright, and that ends section 6.6.